Hi, I'm an old guy and I do maths. What is an ellipse? Well, the short answer is it looks like the graph of a circle that has been squashed, either along the x-axis or along the y-axis. So if I were to draw one here, it would look a bit like that, or possibly a bit like that. So as you can see, there are elements in here of what you might regard as the general equation for a circle graph. The key thing is, of course, that the equation for an ellipse has some extra features. So let's just go into those, and then we'll have a look at a simple equation of an ellipse and how you plot it and how you go about finding the points on it. So it consists of a few parts. The operative parts are on the left-hand side here. We have x minus h all squared over a squared, which is often written not as a squared but as a simple numeral, such as 4 or 9 or 25, if it's one of those nice squares, and y minus k all squared over b squared. Again, that is written generally as a numeral, a simple numeral without the square. You have to find the square root of it to go to work on it. Now, the center of this thing, if we take these examples, which are centered on the origin, this would be 0 and this would be 0. So the center of it would be hk, the origin, 0, 0. If, for instance, this were 2, so it is x minus 2, the x-coordinate of the center would be 2. And if this were y minus 1, the y-coordinate of the center would be 1. This works in exactly the same way as, for instance, the way in which parabolas are moved left and right by having either plus or minus in here. So the center in this case will be hk. Now, what happens is, and I've put this down here just really for information, xy is translated as you see x plus h, y plus h here. So that's what goes on. Now, how we get this distension along one or other of the axes is as follows. That's this little thing here and here. So distension along the x-axis is 2a units. The x-axis length is 2a units. So if this number were 9, the length of this from here to here would be 2 times 3. 2 times a, not a squared, 2 times 3. And up here, if this were, say, 25, we'll say this is 25, the axis length from here to here would be 2 times 5, 10. Okay, so I hope that that's a decent enough grounding. Now what we're going to do is we're going to have a look at a real example. And as they say on cooking programs, here's one I prepared earlier. Now, our equation is x minus 1 all squared over 9 plus y minus 1 all squared over 4 equals 1. And what I'm going to do, just to make this a little easier, is I'm going to write this as 3 squared and this as 2 squared. And hopefully hopefully that that avoids some confusion. Now, our center is 1, 1. That's this point here. So that is 1, 1. And we get that from this equation in this form. The distance through the origin from the bottom of this thing to the top of this thing we find by multiplying, in this case, 2 by 2. So if this is 1, 1, this is 1, 3, that distance is 2, and this is 1, negative 1. So hopefully that makes sense. Going across here, what we have is we have x minus 1 all squared over 3 squared. So a, in this case, is 3. So we have 1 plus 3, which is 4, and the y value remains the same, so we have 4, 1. And we have 1 minus 3, which gives us negative 2, 1. And these are the critical points on our ellipse. And I'm sorry about my drawing, but that very roughly is what our ellipse looks like from this equation. Now this is a starter video. I don't want to go further into this, but those are the very, very basics. Find your center. You can use these to do that. And your extremities are your center point plus or minus a and b. And the distance across here is 2a. The distance up here is 2b, which is why sometimes it's handier to change the form in which this is written to 3 squared and 2 squared, as I did in this case. Thank you very much for watching. I hope that this has been an understandable introduction to ellipses. If you found this useful, please like and subscribe, and I will see you next time. Bye.